Alright, so in this video we're going to look at the solutions and how to do this quiz over lessons 2.4 to 2.7. And again, just as in previous videos, the order of the questions on your quiz more than likely are going to be different than the order in the questions on mine. So let's go ahead and see what my first question is going to be here. Okay, so this one it says, suppose y varies inversely to the square of x, and y is 294 when x is 3. Oh, there's a typo there. I'll probably fix that before you see this. So we need to find out the value of k, the constant of variation, and find out what y is when x is 7. Now the first thing I notice, it says y varies inversely to the square of x. So remember, that means that it's going to be in the form y equals k over x squared. So that's my first step, just to write a general equation so I know what form I'm going to be working with. And then we know that y is 294 when x is 3. So now I'm going to use the value when y is 294, put that in for y, equals k divided by, and I'm going to put the value when x is 3. So it'll be 3 squared. Now don't forget to square the 3 there. Now we can just, to solve for k, we don't divide by 3 squared. You would, in order to get rid of the fraction, we're going to multiply both sides by 3 squared or multiply both sides by 9. And when you do that, you get your value for k. And k would end up being 9 times 294 is 2,646. So that would give us our specific equation. So we would say y equals 2,646 divided by x squared. And what we're going to do now is we're going to use that equation to answer the question. Oh, and by the way, we just found that k is 2,646. Alright, so now we're going to find out what y is when x is 7. So now we're going to take 2,646 divided by 7 squared, which is 49. And when you do that, you end up getting 54 as your answer. So when x is 7, y would be 54. Alright, so this one we're going to fill in the blanks to make a true statement. An exponential function represents exponential decay when so now we've got to figure out what value. Remember, we always refer to, or we determine whether it's exponential growth or decay based on the value of b. When the b value is, and it's going to be exponential decay when b is between 0 and 1. The graph of this would be it's not going to be a straight line, it's not going to be a parabola, it's going to be a curved line. And if it's exponential decay, it's going to be decreasing from left to right. Alright, so looking at this one, so it says we need to figure out what the y-intercept would be. When it's in standard form, remember the y-intercept is always whatever the c value is. Now this is a minus 30, so we would say y equals negative 30. Alright, so then this one, it says, suppose Ms. Murphy found the h value of the vertex to be negative 5. Show your work for how you would use this answer to find the k value of the vertex. And the vertex being the coordinate hk. So for this problem, I just want to make sure that you know how to get your answer, the work that you would do. So the first step would be to put negative 5 in for x. So in each of these blanks, I'm going to replace, again, x with negative 5. And now what you would do is you would type that all in on your calculator. Now if you type that in your calculator, you want to make sure that you put in the negative 5 in parentheses. If you don't do that, you're going to end up getting the wrong answer. Because otherwise, all you're doing is you're telling the calculator to square the 5, not the negative. So that's why it's just good to be in that habit of putting, anytime we're going to input a value into an equation, always putting it in parentheses. And that way you don't have to think whether it's positive or negative. Just always do that. And when you typed it in your calculator, you should get 50 as your answer. Alright, so this one is similar to the one that we just did a minute ago, but this time it says, suppose y varies inversely to x. So it doesn't say square of x, just y varies inversely to x. And y is 21 when x is 5. So we're going to find the value of k and find y when x is 15. Again, there's a typo in there, but I'm guessing that you won't see that typo because I will fix those. Alright, so I'm going to do the work over here. So again, we want to find the value of k. So we know that y varies inversely to x. So we'd say y equals k over x. And we know specifically that y is 21 when x is 5. So we'd say 21 equals k divided by 5. So now to find out what k is, just like we did in the previous one, I'd multiply both sides by 5. So in that way, those 5s cancel out. So we'd have 5 times 21, which is 105. So now to find y, so now we can write a specific equation if I wanted to. So we'd say y equals 105 divided by x. But then specifically, we want to find out what y is when x is 15. So we take 105 divided by 15. And when you do that, you end up getting 7 as your answer. So y equals 7. All right, so here for this one, we're going to do the same idea as one of the ones that we did previously. We're going to show our work for how we would find out what h is. Remember, h is the opposite of b over 2a. So b in this case is 12, so the opposite of 12 would be negative 12. And a is 3, so 2 times 3 is 6. And so negative 12 divided by 6 would be negative 2. All right, so for this one, we're going to find the values of h and k. So now this time we're going to actually go through the process of finding h and k. Then we're going to determine whether or not it represents a maximum or minimum value. So remember, to find out what h is, just like the problem we just did, we're going to do the opposite of b divided by 2a. b in this case is 4, so the opposite of 4 would be negative 4. A in this case is a negative 1/2, so 2 times negative 1/2 would be negative 1. And negative 4 divided by negative 1 would be a positive 4. So h is 4. So to find out what k is, we're going to replace x with 4. So we'd have negative 1/2 times 4 squared plus 4 times 4 minus 2. Well, this we can do with a calculator or without a calculator. 4 squared is 16. Negative 1/2 of 16 would be negative 8. And then 4 times 4 would be 16. So negative 8 plus 16 would be 8. And 8 minus 2 would be 6. So our k value would be 6. So the vertex here would be at the coordinate 4, 6. Does a vertex represent a maximum or minimum value for the parabola? Well, the fact that a is a negative number means the parabola is going to open downwards. And if it's opening downwards, now that vertex is going to be the maximum or the highest point. So we'll type in max here. All right, find the values you need to write an equation of an exponential model passing through the points 136 and 3 and 2.25. All right. So for this one, remember, anytime we want to find an exponential equation going through 2 points, we're going to start with the coordinate with the largest x value. Remember, it's in the form y equals a times b to the x power. So for this one, y is 2.25 and x is 3. And for the other one, we'd have 36 equals a times b to the first power. So remember the next step, so that's your first step. Your next step is to divide. Now when you divide, the a's cancel out. And 2.25 divided by 36 is going to give us 0.0625. And b cubed divided by b to the first would be b squared. So remember, we don't, to solve for b, what we do is we take the square root of each side. So if I take the square root of 0.625, we get our value for b is 0.25. So we can write your answer as a fraction or as a decimal, but don't round, so we'll just say 0.25. Or you could have put 1/4, or you could have put 0.25. Any of those would have worked. Okay, so now we want to find out what a is. So we know the value for b is 0.25, and we can use either coordinate. I'm going to use the 1 and 36. So I would have 36 equals a, which I'm trying to find, times 0.25 to the first power, which would just be 0.25. So to find out what a is, we would divide both sides by 0.25. And when you do that, you would get 144 as your answer. So our value for a is 144. All right, here's another exponential problem. It says the number of mold bacteria in a piece of bread was 8 spores per square inch after the first day of an experiment. If the mold is growing exponentially at a rate of 20% each day, find the number of spores per square inch at the end of the month, if there are 30 days in the month. First, tell me what you would use for each value. Okay, so our A value, remember that's your initial amount, what we're starting with. We're starting with 8 spores of bread on the first day. And our growth factor is not 20. It's not 0.2. It's increasing at a rate of 20% each day. It's growing by 20%. Remember we talked about that if it's growing by a percentage rate, we have to add that to 100. Because you have 100% of what you had before, plus an additional, in this case, 20%. So you have 120%, which as a decimal would be 1.2, or you could say 1.20. And for x, that's going to represent the, it says find the number of spores per square inch if there are 30 days in the month. So 30 would be our value for x. So it says based on your values, how many spores would there be at the end of the month? So we're going to just type this in. So it'd be A, which is 8, times B, which is 1.2, to the x power, which is 30. And if we do that, we get 1,899. So we just do 1,899 would be your answer. Okay, so here we're going to have a drag and drop. It says potassium 42 has a half-life of 12.4 hours. How much of an 848 gram sample of potassium, negative 42, will be left after 62 hours? Label the diagram with how you would set up the problem. Okay, so our initial amount would go outside of here. Our A value is the 848 grams. Since this is a half-life problem, our growth factor will always be 1/2. Remember, for our exponent, it's always the length divided by the length of your half-life, or your time divided by your time of your half-life. And so potassium 40 has a half-life of 12.4, so 12.4 would go in the denominator, and the 62 hours would go in our numerator. So here's a real-life problem. This is actual real data for the state of Minnesota. On April 1st, 2020, there were about 700 total confirmed COVID cases in Minnesota. On June 1st, there are about 25,200 total confirmed cases in Minnesota. That X represents the number of months after January 1st. So use 4 for April and 6 for June. Find the values for A and B that would be used to write an exponential model based on this data. Okay, so there's another typo there. Again, I made this video right after making the quiz, and so obviously there's a few typos in here that I'm going to have to go back and correct. But anyhow, so we want to find the values of A and B. So here's what we know. We know that on April 1st, now April is the 4th month of the year, there were 700 cases. And on June 1st, which is the 6th month of the year, there were 25,200 cases. And we want to find the values of A and B here. So this is one of those equations now that we're just going to find. We're going to set up two separate equations using y equals A times B to the x power. So we're going to start with the coordinate with the largest x value. So we're going to say 25,200 equals A times B to the x power, which is 6. Now we would have the other one, 700 equals A times B to the 4th power. So next we're going to divide those. So the a's would cancel out. So when I take and divide 25,200 divided by 700, we get 36. And b to the 6th divided by b to the 4th would be b squared. So if I take the square root of both sides, we get b equals 6. So we know our value for b is 6. Now we've got to find our value for a. So based on this data, what would the starting amount be? So again, our equation would be y equals A times B to the x power. Well, we're going to use one of these coordinates. It doesn't matter which one. I'm going to use a 700 equals A times B, which is 6, to the x power, which would be 4. So if we divide, so 6 to the 4th, that's going to be a big number. It doesn't matter. But if I divide both sides by 6 to the 4th power, we'd end up getting if we round to the nearest tenth, we get a value of A, which should be 0.5. By the way, if you would have used the other coordinate instead, you would get a slightly different answer, but when you round to the nearest tenth, it ends up being the same exact value as 0.5. All right, last problem. So for this one, we're going to use a quadratic formula to find the x-intercepts based on this equation. So remember, it starts out with the opposite of b. So b is already negative 4, so I'm going to find positive 4 here. So I'll put that out in front. And then it's going to be, now we're going to have to do a little bit of work here. We're going to have to simplify what's underneath the root. So it's going to be the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So what we want to do right now is I want to figure out what goes underneath the root, the b squared minus 4ac. So b in this situation, like we said, is negative 4. So we're going to have negative 4 squared minus 4 times a is 2, times c, and c is negative 30. And when you do this, you're going to end up getting 256 as your answer. And then lastly, we're going to divide by 2a. A is 2, and so we're going to use 4 again down here. So that would be your answer for this last problem. All right, so that's it. So that's the last question on the quiz. So hopefully that answers the questions that you had as you're going through it. And again, if you ran out of time, because I know some people got very close or did run out of time, it's important that you know your information going into the test, because not only will the test have questions from this quiz, but also from the first quiz. So if you don't know your material, if you're having to go back and go to your notes a lot, you're going to find yourself running out of time again on the test, which you don't want to have happen, because the test is a bigger portion of your grade. So with that, good luck now as you continue to prepare for that test coming up.